In this module, you will learn about uniform circular motion. Let's consider the movement of the seconds hand in a clock as the clock ticks. The tip of the hand moves in a circular path, covering equal distances in equal time intervals. Thus, the speed of the tip of the seconds hand is constant or uniform. In each time interval, the hand subtends the same angle at the center of the clock. Such a motion, when an object moves in a circular path with uniform speed, subtending equal angles at the center of the circle in equal intervals of time, is called uniform circular motion. Let's consider an athlete moving along a square track. We'll assume that the athlete runs with uniform speed throughout the track. To stick to the track, he needs to change the direction of motion along the track at every turn, that is, 4 times in one lap. Let's assume now that the shape of the track is changed to a regular octagon, which consists of 8 equal sides. In order to stay on track, the athlete now needs to change his direction of motion 8 times in one lap. Thus, even though the magnitude of the velocity of the athlete is constant, the direction of his motion is changing at every vertex of the octagonal path. If the number of sides of the track increases much further, the shape of the track eventually converts to a circle. On a circular track, the athlete needs to change the direction of his motion at every instant. As you can see, the direction of motion changes continuously, while the change in his velocity is only in the direction and not in magnitude. Therefore, the athlete has an accelerated motion. Hence, an object moving in a circular path with uniform speed has an accelerated motion. How would you calculate the velocity or the distance covered during uniform circular motion? Let's analyze the example of an athlete who is running along a circular track. The distance S covered by the athlete at the end of one lap is equal to the circumference of the track. S is equal to 2 pi r. The speed of an object is the ratio of distance to time. Hence, the speed of an object in uniform circular motion is v is equal to 2 pi r divided by t, where r is the radius of the circular track and t is the time taken to complete one lap in the track. This time is also referred to as the time period. Thus, you can use this formula to determine the speed of an object in a uniform circular motion.